Compound interest is the eighth wonder of the world. He who understands it earns it. He who doesn't pays it. Albert Einstein. So I'm going to show the compound interest formula, which looks a little bit daunting at first, but once you actually use it, it becomes a lot simpler, or a lot more simple, whatever the correct use of English is. And I'm going to show the rule of 72, which is 72 divided by the interest rate will give you approximately how much time it will take to double an investment. So here we go. Here's the nasty looking formula. A equals P in parentheses 1 plus R over N in parentheses to the NT power. A equals final amount, P equals initial principal balance, R equals interest rate, N equals number of times interest applied per time period, and T number of time periods elapsed. All right, here's a little breakdown. Let's do 100,000 as the principal times 1.1, so that's 10% interest to the 30 years, 1.7 million basically. So basically, to keep it simple, I used the principal balance being 100,000, and then 1 plus R over N. So you have R, the interest rate, so that ends up being, so I used 0.1. Remember, interest rate as a decimal is 0.1, that is 10%. So that's pretty straightforward, right? Number of times interest applied per time period. The time period, 1 year. Annual average compound interest, 1 year. So that simplifies it. So now we have A equals 100,000 times 1.1 to the, remember, N is going to be in this situation just 1. So it makes the equation much easier, to the T, number of time periods elapsed. So I did 30 years, basically. So I took out the calculator, basically moved it horizontally on my iPhone, and did 100,000 times 1.1 to the 30th power. And if you have the N is simplified basically to like just number of times interest applied per time period. So say it's only annually, so it's 1 time per year, right? Number of times that interest is applied per year. So if you do annual compounding interest, then it makes this formula much easier. But say if you're in school or if you're taking SAT, of course they've got to throw you a curveball to make it much more difficult. But anyways, I like to keep it simple. So, what's the takeaway? Basically $100,000 initial investment, if it compounds at 10% per year for 30 years, that's 1.7 million at the end of 30 years. That's what that shows. So I guess the question is, first of all, how do you find $100,000? Two, how do you keep it in an investment that averages 10% over a 30-year period? So anyways, a cool formula. It looks so daunting, but it's really not. That N is probably the most difficult thing to kind of overcome in this. But once you figure out, hey, if you do annual compounding interest and you just make that N just 1, it makes this formula so much easier. So sorry to beat a dead horse here. So this is the rule of 72, which 72 is a constant and R is your annual rate of return, essentially. So 72 divided by 10%, or 72 divided by 10 is approximately 7.2 years for the initial investment to double. So say you have an annual average compounding interest of 8%, then you would take 72 divided by 8, and that would spit out a number, and that would be the number of years approximately it would take for your investment to double. So if the S&P 500, the annual average rate of return for the last, say, 50 years is 8%, then you can calculate that, basically how much time approximately it will take to double an investment. And if you know the average appreciation rate for real estate, you can use this, essentially 72 divided by whatever you think that the annual average return will be on real estate, and that will give you the amount of time real estate will take to double in value, if that makes sense. This is kind of a much easier way of getting information as compared to the compound interest formula. I think the compounding interest formula is more precise. But, say you had 72%. 72 divided by 72 equals 1 year, approximately, it would take your investment to return. So just a really cool way to, assess, values and everything. The rule of 72 and the compounding interest formula.